EIGRP v6. In this video, I'm going to talk about the EIGRP for IPv6. You know that in previous videos, we have learned about the EIGRP for routing of the IPv4. And now we will talk about the EIGRP for IPv6. Actually, EIGRP doesn't have multiple versions, okay? EIGRP has one version, EIGRP, okay? But when you are using EIGRP for routing of the IPv4, we call it EIGRP for IPv4 or EIGRPv4. And when you are using the EIGRP for routing of the IPv6, we call it EIGRP for IPv6 or EIGRPv6. You know that in EIGRP we are using the PDM. PDM is the abbreviation of the protocol independent module, and the means of the PDM or protocol dependent module is that in EIGRP, with the help of PDM, okay, we can route different routing protocols. For example, we can different routed protocols. For example, we can route IPv4, IPv6, IPX, AppleTalk. Okay, you know that all of them are routed protocols. And because of that, with PDM, we can have unique neighborship table for IPv4 and unique neighborship table for IPv6. We can have unique topology table for IPv4 and unique topology table for IPv6. I will show you, but let me to give you one example. Assume that here we have router 1 connected to router 2. Here we have configured the 10.120/24 as the IPv4 between these two routers, and also this range of IPv6, for example 2001 db8 1 2, okay, double column /64. Okay, after configuration of the EIGRP between the router 1 and router 2, we will have two neighborship, two independent neighborship. IPv4, okay, neighborship table, and also IPv6 neighborship table. In the IPv4 neighborship table of the router 1, okay, we have 10.122 as the neighbor, okay, means the router 2. And also in the IPv6 of the IPv6 neighborship table of the router 1, okay, we have the for example 2001 db8 1 2 double colon 2 as the for example neighbor. And also about the for example topology table, we will have two independent topology table. Don't forget, you can enable only IPv4, only IPv6, or dual stack, means both IPv4 and IPv6. Actually, we are using EIGRP, okay, with the PDM module for separating the topology table, neighborship table, EIGRP process for the IPv4 and also IPv6. Also, let me to say that many of the concepts, almost all concepts between the EIGRPv4 and EIGRPv6 are same. I will show you these concepts. I will review all of the concepts that we have learned before about the IPv4 in this video, about the IPv6, and also about the configuration, and also some concepts. For example, the first similarities between the EIGRP for IPv4 and EIGRP for IPv6 is that both of them are sending directly over the IPv4. This means that assume that in the EIGRP for IPv4 we had EIGRP hello message. You know that we are encapsulating EIGRP v4 hello, means EIGRP for IPv4 hello, directly over IP with the protocol number of the 88. Okay, you have seen these packets before. Okay, and let me to say that in the EIGRPv6 again we have EIGRPv6 hello. Okay, and we are sending the EIGRPv6 over IPv6, okay, and the protocol number is again 88, and here we are using the IPv4, and this is the EIGRPv4 hello, this is EIGRPv6 hello. As you can see, we have similarities related to the packets of the EIGRP. I will show you. Also, you know that for some reasons, for example, for the dynamic neighborship in the EIGRP for IPv4, we are using the multicast address of 224.0.0.10. In IPv6, in EIGRP for IPv6, we have again one reserved multicast address, and the reserved multicast address for the IPv6 EIGRP is the FF02:A. A means 10, okay? This is the similar of the IPv4, okay? But because this is IPv6 address, you know that this is obvious that this should be different. But as you can see, this is like the translation of the multicast IPv4 in the into the multicast IPv6. Also, about many things we have similarities. Here you can see a table. In this table we are comparing the EIGRP for IPv4 and also EIGRP for IPv6. You know that with EIGRP for IPv4, this is the EIGRPv4, we are routing the IPv4. Actually, you can use the EIGRP for IPv4 or EIGRPv4 for routing the IPv4 packets, not the IPv6 packets, and this is IPv6 networks. Okay, this is obvious, but in the and also in the EIGRP for IPv6 we are routing the IPv6 networks. This is obvious. For example, here when you are enabling the EIGRPv6, you can advertise the address of the loopback from the router to the router 1, but with the EIGRP IPv4 you can advertise the IPv4 networks. After that, about the layer 3 protocol for EIGRP message, you know that we are sending EIGRP message directly over the IPv4 and EIGRPv6 message directly over the IPv6. The layer 3 header protocol type is 88, as I have shown you, and again for the IPv6 we are using the same and protocol number. After that, about the UDP port, you know that none of the EIGRP for IPv4 and EIGRP for IPv6 are using the UDP. Actually, they are sending their traffic directly over the IPv4 or IPv6. You know that in IPv4 we have some concepts related to the EIGRP. For example, we know about the successor. Successor is the path with the lowest metric, and also we have feasible successor. Feasible successor is a path that can pass the feasibility condition. Okay, these concepts exactly are existing in the EIGRP for IPv4 and EIGRP for IPv6. I will show you, but all of them are available in EIGRP for IPv4 and also EIGRP for IPv6. Also, dual or diffusing update algorithm is available in the IPv4, exactly same in the IPv6. Support VLSM or variable length subnet mask. Yes, both of EIGRP for IPv4 and EIGRP for IPv6 support the VLSM. Can perform automatic summarization. You know that in IPv4 we have the concept of classful networks and also classless networks. Because of that, you know that we have the concept of summarizing in the boundary of the two classful network. Okay, because of that we call it the automatic summarization. In the IPv6 we don't have the concept of classful networks at all. Because of that we don't have the concept of the auto summary. When you don't have the classes of the IP address in, for example, IPv6, the automatic summarization doesn't have any meaning. After that, uses triggered update. Yes, in EIGRP for IPv4 we are sending only the updates when we are experiencing one for example change in the network. Look at here. Assume that we are talking about the EIGRP for IPv4. Here we have one network 192.168.10/24. You know that R1 should send only one time this network to the router 2, 192.168.10/24, and the R1 doesn't send the 192.168.10/24 in any interval. Okay, for example, in the RIP or routing information protocol, we should send each network address in each 30 seconds in some intervals, okay? But in the EIGRP, we are sending only one time the network to the router 2, and only when the 192.168.10/24 experiencing some change related to the fail, or for example adding one network, changing the metric or some other things, we are sending the update. And because of that, we are using actually in the EIGRP the incremental update. Incremental update means we should experience some change for sending the update. Incremental update is a method of sending the updates that is more efficient than the interval update. Exactly, we have the same function, we have the same behavior in the EIGRP for IPv6. We call it triggered update, uses triggered update. Default metric bandwidth and delay. About the metric, you have learned about the for example EIGRP classic metric, EIGRP white metric. Let me to say that everything that you have learned before now is available in the EIGRP for IPv6. That's it. Everything is same with the EIGRP for IPv6 or EIGRPv6. And finally, multicast update destination in the IPv4 is 224.0.0.10, and in the EIGRP for IPv6 is FF02:A, not 10. Here we have one mistake in this table. Let me to correct it. This is not correct. We should use the FF02:A. That's it. Okay. And with this table, you can easily understand many of the features that you have learned before are similar between the EIGRP for IPv4 and also for the EIGRP for IPv6 or EIGRPv6. You know that about the configuration, okay, we have configured the EIGRP for IPv4 with two methods. The first method was classic AS mode, and the second method was named mode. Again, exactly we have the same condition in the EIGRP for IPv6 or EIGRPv6 configuration. We can configure the EIGRPv6 configuration with the classic AS mode or with the named mode. I'm going to talk about the configuration step by step. We can review everything that we have learned before for IPv4. Let me to talk about the EIGRP for IPv6 configuration, and here I'm going to show you different methods of configuration. The first method, you know, is the classic method, classic AS method or traditional method, and the second method is the named method. Here we have three routers, router 1, router 2, router 3. I'm going to configure the router 2 with the classic method, the router 1 with the named method, and router 3 with the named method. Okay, this is the classic AS mode configuration. Okay, classic AS mode configuration. Let me to say that in most cases, okay, we have similarities between the classic AS mode configuration and in the IPv6 and in the IPv4. Also, we have some differences. Look at here. The first thing that you should ensure that first you should enable the IPv6 unicast routing. You know that for each type of routing that you want to use in the IPv6, you need to enable IPv6 unicast routing. After this command, you can start the configuration of the routing protocol, IPv6 unicast routing. That's it. Now, let me to talk about the EIGRP configuration. In the IPv4, we are using router EIGRP AS number. Here, we should use IPv6 router EIGRP AS number. So similar. Also, here, we are entering to the router config RTR, not router config router. Why? Because with this new prompt, we can understand that we are residing in the IPv6 process of the EIGRP. The first thing that you should configure is the EIGRP router ID, and again we have the similar router ID with the IPv4. Let me to explain it. You know that in EIGRP, we are using the router ID for identifying one router inside one EIGRP network, okay? And let me to say that the EIGRP router ID, okay, is containing 132 bits value, okay? 32 bits value. This is not IP address. This is like the IP address, but not the IP address. Yes, we can configure EIGRP router ID quad 1 in IPv4 and in IPv6. Maybe you wonder why we should configure the quad 1 in IPv6. Maybe you think that we should configure one IPv6 as the router ID. Let me to say that don't forget, we are talking about the same EIGRP, okay? Only the addressing means in the PDM now we are using the IPv6 routed protocol. Because of that, everything about the EIGRP is same, okay? And this is not the IP address. Because of that, you shouldn't expect to see this value as the IPv6 because this is not IP address. If in your router, for example, R1, you have one interface, okay, that interface has IPv4, you don't need to configure the router ID because in the IPv6 also, you don't need to configure the router ID because the router ID by default is selecting, okay, is choosing with the help of a highest IPv4 for the loopback, and if the loopback is not available, highest IPv4 of the non-loopback interfaces. But if you don't have any IPv4 address interface on the router, you should configure it. Because of that, you know that in IPv4, EIGRP for IPv4, every time we have the at least one IP address, IPv4 address on the router. Because of that, we don't need to configure this command. But in IPv6, this is possible that we don't have any IPv4 address on the router. Because of that, we should configure it. Don't worry, if you have one IPv4 in the router, okay, you can, for example, forget this command, but it is recommended to configuring the EIGRP router ID in the IPv6, but the format is like the IPv4. But you know that this is not the IPv4, this is router ID. After that, okay, after configuring the router ID in the EIGRP, you know that in the IPv4, we are configuring network statements, but in the IPv6 EIGRP, we don't have the command of network. We should enable the EIGRP on each interface independently. Interface name, okay, and then on that interface router config if, we should configure IPv6 router EIGRP AS number. That's it. Okay, let me to show you one simple example. For example, here we have router 2, okay, and in router 2 we are using in this interface 2001 DB8 1 double colon 12, okay, double colon 1/64. This is the IP address of this interface. Okay, I'm going to enable the EIGRP on the